In this video, I am going to explain some numerical problems related with series and parallel combination of resistors. Let us see the question number 1. In the adjacent circuit, calculate the value of X if the equivalent resistance between the points A and B is 4 ohm. Here 4 resistors are connected. These two are in series, these two are also in series. This result, both are connected in parallel, and the equivalent resistance already it is given 4 ohm. So let us start. R1 I am taking, this is the 4 ohm. R2 is equal to 8 ohm. R3 is equal to X ohm. R4 is equal to 5 ohm. Now these two are in series, so I can say that this R dash is equal to R1 plus R2 is equal to 4 plus 8 is equal to 12 ohm. These two are connected in also in series. So R double dash, I can say that X, this is R3 plus R4 is equal to X plus 5 ohm. But the equivalent resistance between them, it is given 4 ohm. So at first we will find the equivalent resistance. 1 divided by R is equal to 1 by R1 plus 1 by R double dash is equal to 1 by 12 plus 1 by X plus 5. So here equivalent resistance is given 4 ohm. So I can write that 1 upon 4 is equal to 1 upon 12 plus 1 upon X plus 5. Implies that 1 divided by 4 minus 1 by 12 is equal to 1 by X plus 5. Implies that this is the 12 is the LCM. This is 3 minus 1 is equal to 1 by X plus 5. Implies that this is 2 upon 12 is equal to 1 upon X plus 5. Implies that 1 upon 6 is equal to 1 upon X plus 5. Implies that X plus 5 is equal to 6. Implies that X is equal to 6 minus 5 is equal to 1 ohm. So we got the value of X, which is not given in the circuit, is equal to 1 ohm. Now let us move to the second question. Question number 2. One circuit is given. You have to find the equivalent resistance between A and B. Find equivalent resistance between A and B. Circuit is given, this is the question. Then what we have to do? Now listen carefully. This is also 1 ohm. These three are connected in series. These three is connected in series. This total 3 connected in parallel. So I can say that here R dash is equal to 1 plus 1 plus 1 is equal to 3 ohm. This is R double dash is equal to 2 plus 2 plus 2 is equal to 6 ohm. Now these three are connected in parallel. So I can say that 1 upon R is equal to 1 by 3 plus 1 by 6 plus 1 by 2. This is equal to 6, 2 plus 1 plus 3 is equal to 6 upon 6 is equal to 1, or implies that this R is equal to 1 ohm. Now these three are connected in series. So the equivalent resistance, the final resistance, the equivalent resistance between A and B is 1 plus 1 plus 1. These three are in series. 1 plus 1 plus 1 is equal to 3 ohm. So we got the equivalent resistance is 3 ohm. Question number 3. In the adjacent network, calculate the equivalent resistance between the points A and B and A and C. Let us see. Question number 3. We have to find out the resistance between A and B. So I can say that these three are connected in series. So R1 is equal to 2 ohm, R2 is equal to 2 ohm, R3 is equal to 2 ohm. So I can say that this R is equal to R1 plus R2 plus R3 is equal to 2 plus 2 plus 2 is equal to 6 ohm. Again, this R4 also connected with this R in. Now I can say that R and R4. You can take this is R4, R1, R2, R3. R and R4 are connected in parallel. So I can say that the equivalent resistance between A and B 1 upon R dash is equal to 1 by 6 plus 1 by 2. This is 6 LCM, 1 plus 3, this is 4 by 6 are equal to 2 by 3, implies that R dash is equal to 3 by 2, this is 1.5 ohm. This is the equivalent resistance between the points A and B. Now second case. So this is the first part. Second part. We have to find out between A and C. So I can say that R dash is equal to R1 plus R2 is equal to 2 plus 2 is equal to 4 ohm. Similarly, R double dash is equal to these two also in series. R 3 plus R4 is equal to 2 plus 2 is equal to 4 ohm. Now these two are in parallel. So I can say that is equal to 1 upon R1 R dash plus 1 upon R double dash 1 by 4 plus 1 by 4, or I can write this is 2 by 4 or 1 by 2, implies that the equivalent resistance is equal to 2 ohm. That means the equivalent resistance between, this is the equivalent resistance between A and C. now let us move to the next question. Next question, what is given? One simple figure is given. In the adjacent circuit, adjacent figure, calculate the resistance between P and Q and between X and Y. Now you see that between P and Q, 3 resistors are connected. So this is the solution for P and Q, 3 resistors are connected. These two are connected in series and this result is connected with this one in parallel. So I can say that suppose this is R1 is equal to 3 plus 3, this is equal to 6 ohm. So you can take it is as R2, R2 is equal to 3 ohm. So R1 and R2 are in parallel. So I can say that 1 upon R is equal to 1 upon R1 plus 1 upon R2 is equal to 1 by 6 plus 1 by 3, this is equal to 6, 1 plus 2 is equal to 3 by 6, this is equal to 1 by 2, implies that this resistance is equal to 2 ohm. Now this total resistance is 2 ohm. Now you can say that now this 3 ohm, 2 ohm and 3 ohm are in series. So I can say that equivalent resistance between X and Y, that is 3 plus 2 plus 3 is equal to 8 ohm. This is the equivalent resistance between the point X and Y. Before that we got the equivalent resistance between P and Q. This is the equivalent resistance between